learn how to code, there'll be times when you're watching us do a demo, and there's times when you'll be coding along and times when you're going, oh no, I just have to pay attention now, and you'll be going, oh, I want to just wish I could just rewind and watch that over, or pause it here while I try something. So I do recommend, in a couple of weeks when you've been playing for a bit, go back to some of the chapters that maybe you were struggling with and review them and stop and pause and try things out, because you'll find that really useful as you're trying to master coding.
How do you get to Carnegie Hall?
Practice, practice, practice.
There you go. All right. Now, as far as our day 2 topics today, day 2 topics today, this is what we're going to be talking about, which is starting off with 2 modules on loops.
Yep.
So we'll start off with 4 loops, and Susan will draw cool little things on her screen. We'll then go into while loops, and I probably won't draw a whole lot of cool things on my screen, but that's okay. We'll then get into lists, multiple items of information. We'll take a look at both writing, reading files. We'll take a look at functions, which is going to help simplify your code, make your code more reusable, and finish it all out with error handling, which one big thing that we want to kind of highlight here is our target audience and who you are. Now, one of the things that you're going to notice about yesterday, one of the things that you're going to notice about today, is we make no assumptions as to programming level.
Yep. So
that we spent a fair amount of time yesterday, for example, talking about the basics of what a variable is, not just simply how to declare it. So if you're relatively new to development and just trying to check this Python thing out, or really just trying to check programming out in general, you're in the right spot. Now, we are going to build on the concepts from yesterday, so I would definitely count yesterday as sort of a prerequisite to today, or the knowledge anyway from there. But even if you didn't watch yesterday and you're still brand new to programming, you're probably still going to pick up a few little things.
I think you'll be able to follow what we're doing today, even if you missed yesterday. There might be a couple of things that you want to go back and check up on later, or read up on later, or check out in the recordings afterwards. But I think you'll still be able to get a lot of value out of the content today, even if you weren't able to attend yesterday. And that's it. We're not expecting you to come with coding experience. If you have never written a line of code in your life, this is still the right place for you to be to learn how to code, and the language we'll be using as we teach you to code is Python.
Yep. Absolutely. That's it. And that really is the key. We're teaching you to code. We happen to be using Python.
Yeah.
Yep. That's really it. Last but not least, the MVA community. 2 million people in the MVA community. You can earn points for attending this little MVA, 50 MVA points. You'll notice the shortcut URL. You'll notice the code down at the very bottom. There is not a new code for today, so there's not a bonus 50 for attending the second day.
Bonus if you get to hear more of Christopher's jokes.
And more hockey references.
Yes. More free toasters.
Yes.
If you were here yesterday, you'll get the free toasters.
Exactly, yeah. And anyway, no spaghetti. That's a different reference.
Yes, I know that reference.
You do know that reference.
Move on.
But anyway, yes, moving on. So what you're going to notice is the fact that you can go get the 50 points if today is your first day. There's the URL, and then away you go from there, which actually is away you go.
So now we're done with our introduction and ready to start digging into some new code.
Exactly.
For today.
Let's do some code.
So let's jump into and talk a bit about repeating events. There are times, yesterday we talked about how the reason we get into coding is because we want to solve problems. And what we do when we're coding a program is really we're solving a problem by writing code. We're getting the computer to solve a problem for us. That's why we write code.
We had this conversation last night about kind of math and programming, and that was the biggest point that Susan made last night. So it's awesome to hear you making that again this morning, that's what you're doing with code. You're problem solving.
Yeah.
That's it.
Yeah. Programs are there to solve problems for us.
Yes.
So as we learn more commands, we can solve bigger problems, more complex problems with our code. And some of the problems that we have to solve involve repetitive actions, things you have to do over and over again. A simple example, you are having a party and you have people coming over, you want to pour a cup of coffee for each guest, right? It's not just pour yourself a cup of coffee. It's like, oh, wait, I've got people at the table. I'm going to pour everyone a cup of coffee.
Exactly.
Wash the dishes until they're all clean. You don't just wash one dish and say, I'm done the dishes. No, you've got to keep washing the dishes until there's no more dirty dishes. Making a name card for each guest that you've got attending a party. When you're having a wedding, your thank you card for each of the people who attended the wedding. There's all these patterns where we're repeating a similar action over and over and over again. And when we are writing code and we have something we need to do over and over, we use loops, and that's our way of repeating a task. So we're going to have a little fun. I'm going to use a well-known actually tool. It's called Turtle, which is something we can use inside Python to actually show you how we can use loops to make our code a little easier and to repeat events. So we're going to use loops, in this case, to do some drawing. So I'm actually to start off by doing a little demo and introducing you to Turtle. So I'm going to go into Visual Studio. If you weren't here yesterday, we're using Visual Studio and Python tools with Visual Studio to do our demonstrations. You can find the installation instructions in that GitHub location. We also have that link up inside the Q&A window if you haven't got it. So
and I'll throw it back up there right now. Just to
good idea. That'd be great. Now, so if I want to use Turtle, Turtle is in a library. So I have to start off by importing the Turtle module. And by doing that, what I'm doing is I'm simply telling Visual Studio that, hey, there's some logic inside that Turtle module that I want to be able to use. And Turtle is, said it's used in other programming languages as well. Turtle is a little turtle who moves around the screen and draws lines.
And for those of you who may remember back to many years ago, this was actually a very common way, and it still is, a common way to teach kids programming. Because what's nice about it is you get all those core concepts about doing things like loops, issuing commands, and it's just kind of fun watching. Oh yeah, cool! I saw a little drawing on my screen, so I still get a charge out of it. I'm 29.
Yeah, exactly.
Yeah.
Yes, you're 29.
I'm
That's
29.
Right. So once we've imported Turtle, then we can call some of the methods inside Turtle to do different actions. Now, so we call the Turtle object, and we tell it we want it to move forward. Now, there is something quirky. I'm not sure what it is. I think my IntelliSense library is out of date. So you'll notice when I hit the period after typing Turtle, there's a list of methods that pop up. And unfortunately, with Turtle, it doesn't list the methods I actually want to be calling. I'm not sure what's going on with that. So you'll see me just typing in the methods I want to call, and every now and then it goes and selects one that isn't what I wanted. So I'm just going to say, let's tell Turtle to move forward 100. Now, when I execute this code, you'll see basically a line that gets drawn that's 100 pixels long. So it draws a 100 length line. And I can go, and then I can tell Turtle to move to the right.
To the right.
And I can tell it to turn 90 degrees. And then maybe I tell Turtle to move forward 100 again. And again, my apologies. I'm not sure. I think my IntelliSense database is a little out of date. So it keeps thinking I want to select a different method every time I type forward. So now you'll see it draws a line.
I like watching it actually draw.
I actually like watching the motion, and then it goes down and draws another line. So with Turtle, we can go ahead and draw different things on the screen. So if you ever there was a toy I used to have as a kid, it was called an Etch-a-Sketch, and it was this little red thing with a little dial, and you would turn it and draw little lines on the screen. I think of Turtle as like Python's Etch-a-Sketch. That's actually how I think.
Okay, I like it.
So we have these awesome little tools that allow us to draw things on the screen. So we're going to be using Turtle in this module to have a little fun and also to introduce the concept of loops. So what I've done is I've drawn a line using Turtle. And if you take a look, there's other things you can do. You can change the color of the pen if you like as well. If you call the color function, you can actually set the pen color to green or blue or red and all kinds of different colors. So if I go here and maybe after I turn the corner, I say turtle.color is red. And once again, the IntelliSense in this case is actually messing me up and trying to change the method on me. Change the color to red. And now you can actually see that the second line that was drawn was actually drawn as a red line. So I can change the colors of the pen, I can move the pen in different directions and draw my object. So that just sort of shows you what Turtle itself can do. Now, I just did some drawing with Turtle, so let me get into a few other commands you might want to play with. If you want to explore Turtle, have a little fun with it. You can rotate to the right, rotate to the left. That's how you make it turn corners to make things like squares, triangles, and so on. You can change the pen color by calling the color function. You can tell it to move forward, you can tell it to move backward. There are more methods than that. If you want, go do a Bing search on Python, Turtle, functions, and you can get a list of all the different functions. You can do things like lift the pen up and put the pen down so you can't actually get gaps between the lines. You can do a stamp to make a little like sort of capture of a little turtle shape at different points on your object. So there's some other functions as well, but this just gives us enough to play with. So if we wanted Turtle to draw a square, you think about what we'd have to do. So we'd have to tell Turtle to draw a line, turn the pen 90 degrees, draw another line, turn the pen 90 degrees, draw another line, turn 90 degrees, and draw another line up to a start. So we basically draw a line, turn, draw a line, turn, draw a line, turn, draw a line, turn. And that should give us a square.
Yep.
Ineffectively, if you actually look at the code we'd get for that on the slide here, what you end up with is you actually get the same 2 lines of code over and over again. Move forward 100, turn right. Move forward 100, turn 90 degrees. So that'll draw a square beautifully, but what we really end up with is just 2 lines of code repeating over and over and over again. This is a perfect situation for using a loop.
Yep.
Because a loop allows us to say, execute these lines of code however many times we want. And that's going to be much easier to work with than having to write the same code over and over. And we talked a bit about this yesterday in terms of good programming practice. It's not a lot of work to copy and paste those 2 lines of code and move them down the screen. You just go copy, paste, 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 paste. But somewhere down the road, I guarantee you, someone's going to say, could you make a triangle instead of a square? Could you make an octagon instead of a square? So suddenly you now need to loop to run 8 times instead of 4 times, and now the angle's got to be different because your angles aren't going to be the same for a triangle as they would be for a square. And if you don't remember to make the change in everywhere where you specify the angle, then the code's not going to work properly. So one of the reasons we don't want to just copy and paste the same code and execute the same 2 lines of code 4 times the way I have it on the slide here is because if we had to make a change later, that's more places we have to go make the change. We might forget to make it in one place, and now we've just screwed up our code.
Exactly. So, I mean, we keep talking about being lazy developers, but just doing that copy and paste isn't being a good lazy developer, because in the long run, you're just making more work for yourself when you have to go back and change something, because now you have to go back and change it in a lot of places.
That's right. All right, so what we're going to do then is we're going to use a for loop to do the same thing. So if we take a look at the slide, I want to take you through the syntax of the for loop. It's fairly intuitive when you look at it. You've still imported the turtle library. I'm still using turtle and telling turtle to move forward 100. So this line of code hasn't changed. This line of code hasn't changed. And this line of code hasn't changed. So we're still importing the turtle module, telling the turtle to move forward 100, and telling the turtle to turn right 90 degrees.
So we basically have the exact same code that we saw already.
Yes.
But now what we're going to do is we're just going to tell it, hey, I want you to do this
4 times. Exactly. So the code we haven't looked at yet is the code that's telling it execute these 2 lines here 4 times. So the way we do that is we use the for loop. The for loop is specifically a loop which allows you to specify a fixed number of times. If you know how many times you want that loop to execute, a for loop works perfectly. So if you take a look at the code, you'll notice I say 4 steps in range 4. So that number 4 is telling my loop how many times I want it to execute. The rest is really just syntax. You have to say for something in and then specify number. So those are the only thing you're going to change is the number here. You get to choose that number. The word range, that's a keyword. You're not going to change that.
Okay.
You always have a semicolon. Yesterday we saw after if statements you need a semicolon. After
colon.
For loops, colon, thank you. After for loops you need a colon. Just like yesterday we saw after if statements you need a colon.
Yep.
You have to indent the code that is going to be repeated. We saw that in if statements yesterday, that it was a way, indenting is a way for us to tell Python, these commands are part of that if statement, or these commands are part of that for loop. So this is the code that will be repeated.
Right. And so again, you know, very subtle, and a lot of people pointed that out when we talked about the if statements. But again, it is something that you want to get yourself into a habit of. Absolutely. Yeah. So, and if we go back to Susan's slide, if I can point out one other very big thing, Susan did something really, really, really good here. And I want to commend Susan for this. So you get the gold star today, Susan. Congratulations.
Are you talking about this word here?
I'm talking about that word.
Because I haven't explained it yet. So let me explain it, and then I'll let you comment right after I explain it.
I want to give you a gold star.
Okay, I appreciate that. So far, really, the syntax, there's nothing you need to think about. It's just syntax. You say for something in range, you specify the number, which is how many times you want to execute, and you have to specify this value here. Basically, this is a variable name that's going to keep track of how many times you've gone through the loop. You can call it anything you want. I just chose to call it steps. Cue Christopher.
Cue Christopher. So one of the big things about steps is that steps there is a variable. So if Susan wanted, she could have called that Wibble. She could have called that
X.
X.
Or I.
It's so painful.
Yeah.
The thing about single letter variables is that they don't mean anything. That if I look at a block of code and I see the letter I, what does that mean? I have no idea. But if we take a look at a block of code and I see the word steps, I know what we're talking about. We're talking about steps. So even if you're not using the variable, still give it a good name. If you ever have the opportunity to name something, give it a good name. That if you have kids or if you have pets, you don't name them A, B, C, D. You give them meaningful names. It's the exact same concept here. Give it a meaningful name. Okay, rant over.
Okay.
You get your gold star.
We get to go back to the slides now?
Yes.
All
yeah,
right.
now
so
I can
we're
breathe.
Back to slides. Awesome. That's great. So yeah, so that's that variable steps. If you look at the slide here, he's talking about that variable steps right here. You can call that X. You can call that, as you said, Wibble. You can call it Bob. But yeah, having a meaningful variable name. You'll see I typically use the word steps because I sort of use that as I think of myself as stepping through the loop. And every time I step through the loop, I'm keeping track of how many times I have stepped through the loop. So that variable steps, the first time I go through the loop, it'll be equal to 0. 0. The second time through the loop, it'll be 1. The next time through the loop, it'll be 2. Because programming in Python, we always start counting from 0. So first time is 0, second time is 1, and so on.
Yep.
All right, so let's go back to the slide. Now we've taken a look at the syntax. And so you can see we specify the number of times to execute the code in the loop. You have to indent the code you want repeated. And if you change the range value here, so here I've changed it to 3. So that means my loop is only going to execute 3 times. So if I was to execute this code, I end up with an incomplete square because it only drew 3 lines on the screen. So you can see how changing the range changes the number of times the code is repeated. And it's also important to recognize that only the indented code is repeated, right? So these 2 commands are repeated. So I've got a loop. It's executing 4 times. That's a significant number there I have to really worry about when I'm writing for loops. The rest is just syntax. You'll look it up when you need to. I specify to execute 4 times. So 4 times, it's going to move 100, turn 90 degrees. So it's going to draw a square. And then afterwards, I tell it to change the pen color to red and go forward 200. So what this is going to do, though, this isn't indented code. So it's going to draw a square. And then when the pen gets back to start, it's going to go off and draw a red line. So if I execute this code, what you end up with is a square and then this red line going across the top. So you can see that the red line did not execute 4 times. It didn't draw a square, a red square that was bigger.
And it's all about that tabbing. So if you would tab that in, that also would have executed 4 times.
Exactly.
Yep.
It's not indented, so it's not part of the loop. It's not repeated.
Perfect.
So I'm just going to take the code I had here, and I'm going to just demonstrate that actual for loop here, and I'm just going to say 4 steps, and just to prove it, for weird name in range, just to prove you really can use any name you want here, in range 4, because I want to execute this 4 times. And now I'm going to have to indent my code.
With tabs.
With tabs, yep, using the tab key there. And now, when I execute my code, I can see it draw my little square.
I just love watching that on the screen.
Yep. And then if I specify that after I'm done, I want turtle to move forward. It's so annoying the way it does
You
it.
can hit escape.
Escape will work for that?
Yeah.
Ah, there we go. Thank you.
You're welcome.
Forward, let's say 200. And again, I'm going to change that pen color as well. I should do that before I move forward. There's no point in changing the pen color afterwards. Turtle.color. To be red or green or whatever color I like. And you will see, just like I showed on the slide, that at the end of my loop, it then goes off and draws that longer line that's colored in red. If I just indented that code, then suddenly these commands will be executed 4 times as well because they're indented. They're now part of that loop. So now, oh, look at that. Woo-wee. Oh, you know what I did, of course.
Yeah.
Within
you
the
left
loop.
it as part of it. Yeah,
That's really funny. I hadn't even thought about it. Because what I did is I said, move forward, then turn right, then change the color to red and move forward again. And do that 4 times. So it caused a little unexpected result there in terms of how it drew it. But you can see, actually the end result in terms of it, it does actually just draw a really big
it did
square
exactly
for
what
me.
you told it to do. Don't you hate it when that happens? It does exactly what you tell it to do.
Computers only do what we tell them to do.
Yes.
It is frustrating sometimes. lines, because sometimes we want them to do what we want them to do, not what we told them to do.
Yep. By the way, can we switch back to Susan's code here real quick? Just because I want to highlight one little thing that came up in the chat. And this is one of those things where and this is true universally, so I guess it's kind of good that we all learn it now, which is sometimes the methods, the properties don't always behave the way that you would expect, that somebody was expecting that color would be a property rather than a method, which I can certainly understand. But yeah, you'll notice that color is a method there, meaning that you're going to say color, and then in parentheses, you've got red there.
Yeah, you're actually calling Turtle, you're calling a function called color, which changes the pen color to red. But absolutely, the person who designed Turtle could have designed that as a property instead of a function if they had chose to. It's just a choice the person who wrote the code for Turtle made.
Yep, exactly. Yeah. And by the way, method and function, those two terms are essentially synonymous. So,
they're generally interchangeable.
Yeah, yep, exactly. Cool.
All right, let's go back to our slides. Okay, so now, Christopher, one of the things we've talked about is that as we write code, we are going to make mistakes. So I have a slide here, and there's 3 mistakes in this code.
Oh, you're doing this to me again.
I'm going to play spot, because one of the things you have to learn how to do is find the mistakes in your code. So can you see 3 mistakes?
Well, I see improt.
Improt, yes, you're right. I have made a type mistake. It's import Turtle, not improt Turtle. I'm putting Christopher on the spot. He hasn't had a chance to look at this before.
You are, and well, I'm seeing the second, but I want to talk about that one at the end.
Sure.
Because that one's a little bit different. 4 steps in range 4. Oh, you need a colon. Thank you.
Yes, that's correct. Good guess, Christopher. Yes, we're missing a colon after the range 4.
Now, the reason that I was kind of holding off on that last one, so you've got, improt Turtle, so obviously that's a typo.
That should be import.
And that's going to give you a syntax error. So that's going to, Visual Studio will typically tell you right away, hey, you've got a problem here. Or when you run the code, it will bomb out on you. With steps, Visual Studio will give you, and this is the technical term, red squigglies to tell you, hey, you've got that wrong. The last mistake that you've got is Turtle 90, right 90.
I probably meant to have that indented, didn't I? Because I'm trying to draw my square again.
And that's one of those, should be indented. A lot of people caught that, which is perfect.
Yep, good catch.
The thing is that's what developers call logic error, meaning that your code is going to execute correctly. It's not going to give you an error message, but it's not going to do what you want it to do, which makes it one of the hardest bugs to try to debug.
Why don't actually we execute that exact
let's do it.
mistake?
We can see it.
And you can see what would happen if I ran the code. So absolutely. If I left off that colon, then I get the little red squiggly, as you said, and yes, that is what we call it, the red squiggly. Or a syntax error or a compilation error. We'll use those terms. But if I forget to indent the turning right, Visual Studio goes, this is valid code. You can do this if you want. But then when I run it, I end up with a really big long line. And I'm like, that's not what I was trying to draw.
And if we actually did, go, 8 billion steps off the page, or I guess 400.
If I made this only 10 wide, you could see it.
Yeah, what you could see at the very end there is you'll notice at the very end that the cursor did in fact turn that 90 degrees to the right. So it did run the code, it did exactly what you told it to do.
But not what I wanted it to do.
Exactly.
Yes. So that is the challenge, is you have to find both the mistakes. Some of the mistakes Visual Studio will help you find. Some of the mistakes Visual Studio can't help you, because what you wrote is syntactically valid. It just doesn't do what you want the code to do.
Yeah, exactly. Yep.
All right. So yes, you have successfully found all the mistakes. Well done to those of you in the audience as well who pointed them out in the Q&A. That's awesome.
Yep. And there's still actually a lot of conversation around that tab, and that is something that's relatively unique. I'm sure there are other places where you will see that. But again, yes, it's subtle. I'm with you on that, but it's a good practice. It's something you would do anyway, even if you did have curly braces or end statements or the like.
Yeah, because some other programming languages, instead of using that indenting, there has to be a way. If you think about it, if you were designing a programming language, you need a way to say which commands should be repeated. You have to have a way of doing that.
Yep.
Some programming languages will require to use certain braces, and you do an opening and close brace around the commands that are going to be repeated. Some programming languages have effectively an end loop command that indicates the loop starts here, loop ends here.
Yeah.
But the interesting thing is, in all those programming languages, as a convention, most of us always indent the code that's inside the loop anyway, whether we have brackets showing beginning and end or an end loop word indicating the end of a loop in the beginning.
It just makes it more readable.
It does. We tend to indent the code anyway because it's more readable. So in a way, Python's letting us be lazy by not having to type a word like end loop or having to add curly braces. We were indenting it anyway, so it was easier to see. When I look at it, I instantly go, oh, that's the code in the loop.
Exactly.
Yeah.
And here we go back to being lazy developers again. You'll notice a theme.
Yes. I encourage being a lazy coder in the sense of it's being an efficient coder. That's what I like to think.
Lazy perfectionism, to bring out the little phrase that we learned yesterday from one of our attendees.
That's
right.
right.
I don't know if he's on board yet this morning, but yeah. So.
All right. So now let's take a look at nested loops, because it is also possible to put one loop inside another. So you can actually have a lot of fun, especially in this drawing tool with Turtle. When you start nesting loops, you can have a lot of fun. So if you think about it, so what I've got my for loop, which is repeating 4 times. And then inside the for loop, this is all nicely indented, but look what else I have indented in the for loop. I have another for loop, and this for loop has to execute 4 times because it's indented. So this is going to be so this will all be done 4 times.
Yep.
And then 4 times, I have a loop that will execute 4 times that draws a slightly smaller line and turns.
What's going to happen is you have 2 loops, so you've got that outer loop, so that's going to execute 4 times, and then each time that it does that, it's going to execute that inner loop 4 times.
Exactly.
Okay.
So if you look at that inside loop, all right, challenge, think about it, those in the QA, how many times is this code going to execute?
There's math again this morning.
Yes, it's math this morning. Is it going to execute 4 times? 8 times, 12 times, 44 times. You got any guesses in the QA window yet, Chris?
Not yet.
Might be a little lag. Sometimes there's a little lag
there's a little bit of a
between
lag
when we're
there.
talking and when you get a chance to see what we're saying.
But
so the answer is
so I'm seeing a couple of people saying 4. The answer is actually going to wind up being
16
There we
times.
go. Yeah, we got and actually, somebody called it out specifically. It'll run 4 times 4. A couple of people actually called it out.
4
And
times
that's really
4.
the best way to think
That
about
is a
it.
good way.
4 times 4, because you've got the outer loop. Inside of that is that inner loop. So the outer loop is going to run 4. The inner loop contains another loop. So it's going to be, while we're doing this, 1, 2, 3, 4. While we're doing this, 1, 2, 3, 4. So 4 times 4 is 16.
Yeah, well done.
Again, there's math this morning.
Yeah. What's really fun, though, is I love the output you end up with. If you draw it, you end up with little squares inside a big square.
It's really kind of funny watching the lag now kick in because, it was a little bit of time and no answers.
And now everybody's got it.
See the Q&A.
Everybody's got it.
16.
You guys rocked it. You knew the answer. I knew you had the answer. It's awesome.
16 will be the number of the day.
Now, I had a little fun. When I was playing around and I started doing nesting loops inside Turtle, I started going, well, what if I do a different shape instead of nested loops? And I had fun. So then now I've got a loop. And the outside loop executes 5 times. And inside, again, I've got a nested loop, and the inside loop executes 5 times.
So 5 times 5, so 25.
Right, so this code is going to execute 5 times.
So that's going to give me a pentagon.
A pentagon, correct. And then this code is going to execute 5 times 5, which is going, 5 times 5 times.
Yep.
Because you guys figured that out, and so it's going to execute 25 times.
Right.
Now, what's interesting, of course, it's doing this along the way. And now you'll notice I'm still moving forward 100, but I'm turning right. My angle that I'm changing is 360 divided by 5. If you want to draw an equilateral shape, is that what you call it when everything's the same size of every side?
Oh, now we're going with geometry.
I know, geometry is
Geometry is actually one of my worst subjects.
Okay, yeah.
Yeah.
So, but if you want to draw a triangle, the angle of a triangle that's going to have 3 sides that are equal size is 360 degrees divided by 3. Do you want to draw a perfect square? Then the angle of each corner is 360 divided by 4 because it's got 4 sides. If you want to draw a pentagon and have exactly the right angle and everything the same side, the angle is 360 divided by 5. So if you have a 6-sided object, it would be, and you needed the angle would be 360 divided by, Christopher, fill in the blank.
I wanted 6?
Yes, 6 is correct.
6.
6 is correct. Now, the fun thing is when
I was answering Q&A questions.
I know you were.
By the way, I do want to mention, because again, we actually now have 3 people that are helping with the Q&A. It's Susan, myself, and
Sonal. Thank you, Sonal.
Yes.
Appreciated.
So we're doing our absolute best to try and respond to as many questions as we can. But if somebody winds up kind of falling through, there's only 2 of us. We're doing our best.
Yes, exactly.
Yeah.
So do be patient if we take a little while to answer a question.
Exactly.
So, but anyway, if you actually go back to the slide here and you look at the shape that's been drawn, it's neat because when the pentagons overlap, you get this funky star shape that ends up appearing on the screen. So you can have a lot of fun when you start playing with the drawing and the nested loops.
Exactly. Yep.
So if we just demonstrate that,
Right on cue.
I'm going to go ahead and add another nested loop here for steps in range 4. So let's do that nested square. And we ask Turtle to move forward 100. Let's make it